Perfect. So welcome everyone. I hope you guys enjoyed the first, part of the week with the girls from NeuroArc, and I hope you enjoyed this. How the week is going so far with the digital futures workshops in general. So we're very excited to be here today, talking to you guys and explaining a little bit of our research. And we're gonna get later on about who we are and where we're coming from. But just wanted to point it out that it's an extreme privilege to be in this platform, Digital Futures. And we personally had classes with Professor Neil Leach, who's one of the people behind the creation of Digital Futures, which is an amazing platform filled with amazing, brilliant people. And these yearly conferences with hundreds of workshops are an extreme a gift, of knowledge, and the whole idea of inclusive futures, the availability for everyone, which is it's a beautiful idea, and it's really good to be part of it.
And we're very thankful to be here.
Next. So just to get started, a little bit about us. My name is Matheus Stancati.
I'm Ligia Filgueiras. We were both born and raised in Brazil. And recently, as Matheus just said, graduated from Florida International University, where we began to study the implications of neuroscience applied to architecture and the potential of emerging technologies with our thesis professor, Neil Leach. And we also wanted to give a disclaimer before we begin.
Yes, we just want to say that we just graduated with a master's in architecture, but we're by no means professional neuroscientists. And what we're gonna expose here is a little bit of a research, and that is why we got invited to participate in this workshop. We had this interest during our thesis semester on exploring this emerging concept of neuroscience applied to architecture. And that is why, because of our studies and the thesis, we got interested and wanted to share with you guys. So a little bit about myself. I was born in Brazil, born and raised in this rural town called Tatuí in Brazil. And in 2016, I moved to the US to start my university career here in Florida. And eventually, my interest in computational design and robotics emerged when I got invited to participate in this project to inaugurate the RDF lab, which is the Robotics and Digital Fabrication Lab. We developed this system, our own system for 3D printing clay for a parametric breeze block, which you can see in this image here. And eventually I got recruited to participate in the Robotics Academy, which was this initiative to bring classes and teaching to train the current workforce in construction and architecture to prepare for this upcoming robotic revolution that people say that is going to change the world of construction. And then later on, many different projects within the RDF and Robotics Academy. Eventually, I got to my final year of the thesis semester, and having Neil Leach, we were exposed to a lot of different, frontiers of architecture and different levels of research. And my interest in neuroscience made me, go towards this idea of, exploring different ways of creating memories or recording memories somehow. The whole studies of cognitive maps and how we can, understand how the brain functions to remember something and then apply that to architecture in a way that we can. These are a couple of experiments during the semester, trying to merge what is, the experience or perception inside a physical space and the perception in the urban environment, and then start mixing both to create this overlap of different memories somehow. And then focusing on this idea, we were quarantined. So how can I change perception inside the place that I'm locked in? And eventually my final thesis project was this idea of modifying perception to based on specific memories and biofeedback, biosensory data from the body. And the idea is once you digitalize, it's a very simple explanation of a larger research, but once you are able to digitalize a physical space, you can then modify the digital, but then align it with reality and experience or perceive this modifications. And I'll go later on, especially on day 2, a little bit more about my project. But now Ligia will introduce herself.
Hi, everyone. I'm Ligia, and I have been an architectural designer now for quite some time during school, and a researcher. And during my master's research, I focused on the intersection between emerging technologies such as automated and speech-driven machines and architecture education. I conducted extensive research on speech recognition tools available to the public and how the implementation of these tools combined with immersive tools such as VR and AR could impact the way we design and the way we learn in architecture school. There are several components to this, especially the interaction between students and the environment, but also how could this technology play a role in this environment. So it was a really interesting topic to dive upon, and if anyone is interested in speech recognition techniques and Unity, feel free to reach out. I have some knowledge on the kind of assets and things available for that. Additionally, during my time at FIU, I was awarded a graduate research fellowship from the FIU Center of Research Excellence in Science and Technology, also known as CREST, which is an incentive supported by the National Science Foundation, NSF. So during this period, I worked with Professor Biana Bogosian, which is one of the founders of Digital Futures as well. And basically, we developed interactive data visualization methods applied to various water quality sensing efforts. We worked alongside with computer scientists and biology students to gather data from local buoys that measured water metrics. And then we created data visualization studies to translate this data to the public.
So just to explain a little bit of what we're going to go through in these workshops, we have a couple of things prepared for you guys, and we're going to start with this intro on neuroscience. And I believe a lot of the things that are important to know, Chris Moon, David Kirsch, Arbib already talked about, and the girls from NeurArc as well, Gabby. We're going to go through a couple of these, then a couple of different perspectives on what neuroscience applied to architecture is, a little bit of case studies, and then we have a lecture by Lori Crizel, who is here, and we're going to introduce him and explain the amazing things he's done in the past before he presents. And then we're going to talk about this metric system of getting data from the building, getting data from humans, and do a little interactive way of explaining those concepts that is not in a typical lecture style. And then on day 2, we're going to dive deeper into what the name of the workshop is, which is the neural networks, focusing on artificial neural networks as a tool for neuroscientific studies in architectural spaces. And if this got you lost somehow, we're going to explain, don't worry. And if by any chance, at any point during this workshop, you guys have any questions, just send a message in the chat, and we're going to see as soon as we can, address them accordingly. And then on day 3, we're going to have an open lecture with Dr. David Kirsch, Lori Crizel, and I believe Chris Moon is going to be there as well. And that is when we're going to have, this no schedule, just conversation about. So the topics are going to create themselves. And that is the time that you guys, if you have any questions throughout this entire workshop, you can craft, a deeper question to be explored by these amazing professionals. So first, let's start with introduction to neuroscience with the question of why. Why is it so important for us to start raising questions about, this overlapping frontiers, and why only now this field is receiving so much attention, even though it's not a new concept or idea. We're seeing left and right people talking about this, and Clubhouse conversations, and AMFA, which is, we're going to go deeper into all of these different organizations from different places, looking at the intersection of these both of these worlds. And a really good introduction of why this is so important, why the brain is so important, was done by Dr. Vilayanur Ramachandra. I'm so sorry, but I can send a link after to his conversation. But he introduces the brain, and I quote, "Here's a lump of flesh, about 3 pounds, which you can hold in the palm of your hands, and you can contemplate the vastness of interstellar space. You can contemplate the meaning of infinity, ask questions about the meaning of its own existence, about the nature of God. And this is truly the most amazing thing in the world. It's the greatest mystery confronting human beings. How does it all come about? Well, the brain, as you know, is made of neurons. We're looking at neurons here. There are about 86 billion neurons in the adult human brain. Each neuron makes something like 1,000 to 10,000 contacts with other neurons in the brain. And based on this, people have calculated that the number of permutations and combinations of brain activity exceeds the number of elementary particles in the universe. And this introduction is particularly meaningful because it shows how much it's a very unknown field. Even though we're having a lot of data about it, we still have a lot to go. And again, this is not a new study, and actually it goes back, if we look at the history of milestones in your scientific findings, we have from 4000 BC, this beginning of questions when Plato's raising questions about, who we are, what human beings are. And then we have throughout history, Leonardo da Vinci produces wax casts of human ventricles, and the whole study of the actual, someone joined, the human body. We start, looking at the human body. And then we have, the card describing I think it's here, around here, which is almost halfway. The card talking about this differentiation between body and mind. And then eventually we have, in 1844, Robert remarked, the first illustration of the 6 layers of cortex, and so on. And only in 1936, we have the very first EEG laboratory. It only took until here, literally here, all of this finding for us to have the beginning of this technology that can map, data.
And in contrast, from then on, from 1950 to the present day, we have had so many technological advancements. And a lot of this now has been applied, to neuroscience. So in 1953, James Watson published a paper revealing the molecular structure of the DNA. Then the Society of Neuroscience was formed. And then there was the progression of the PET scanner, and even President Bush declaring 1990 as the decade of the brain. And President Obama in 2013 developing a whole fund called the Brain Research to Advancing Innovative Neurotechnologies. So the government is actually posing a really deep interest in the brain as well. And I mean, you can look at the past 10 years and see how many advancements have been made, and we can begin to speculate what's going to happen in the next 10, 20 years with the advancements of technology.
And an interesting thing to point out is that, yes, in this past 3 decades, the immense growth of technology gave this species, the human beings as a species, these tools to actually receive and track and record information about the brain. And even though we're not there yet, this might be the beginning or the continuation of this initial stage of a new era of knowledge in the human brain. And now we're starting to get this reliable data. So, what are we doing with it? What are we discovering? And we want to talk a little bit about the importance of data. So why is it so important? And I mean, you can talk about the scientific method, the whole idea of science itself, that is having a question, having some sort of doubt, and then researching about it, constructing a hypothesis, and then testing about it, receiving the data, analyzing data, processing it, and then it becomes a result, but it's always, nothing is permanent, nothing is absolutely true. It's always this constant growth, and doubt itself is what moves this wheel of science forward. And now we're having more and more tools to collect and analyze and process this data.
Yeah, as mentioned by Chris Moon on the introduction lecture, newly developed biometric technologies are becoming increasingly more available and affordable. A few examples are mentioned here, and this technology includes EEGs, fMRI, brainwave sensors, heart rate monitors, biosensors, eye tracking, and facial recognition tools. I mean, the list goes on. And the use of these technologies can help us inform the way we create spaces in not only virtual environments, but also in the future physical environments we create.
And the importance of understanding this data now, there's an explanation by Brian Johnson. And Brian Johnson was the founder of Braintree, which was a payment company that got bought by PayPal. But he also founded Kernel, the company that is developing, the name of the device is it's a TDFNIR, which in a way it shoots light at your scalp, and it measures as light bounce backs, it measures the oxygen in the areas of the brain, meaning that it can track which areas are being lit up or activated. But the thing is, when he explained, in an interview with Lex Friedman not too long ago, like a couple of weeks ago, he explained that if you go to a cardiologist, a doctor for the heart, and you simply tell the doctor how you feel about your heart, and the guy prescribes you medication, you would think that's insane. However, in psychiatric institutions, that is what is happening. People are explaining what is going on, and then decisions are being made in the medical field. And now with this growth of technology and growth of artificial intelligence being able to process data, we're seeing more and more this getting closer to a future in which we can understand what is going on much, much, much better, much clearer. And now I think why everyone is here, and the question that architects are having is, well, how does this apply to architecture?
Okay, so if we look back, basically, and I think it's 1960, Kevin Lynch wrote this book, The Image of the City, and he talks about how people in urban situations orient themselves by means of mental maps. He compares different cities and looks at how people orient themselves in these cities. A legible mental map gives people an important sense of emotional security and is a framework for communication and conceptual organization, heightening the depth and intensity of everyday human experience. You can see here in this image that the way people describe how they perceive the city is also different. And keeping that in mind, I want us to bring this study that kind of supports the idea of this mental map, but really dives it deep into the connection with the brain. So I think you all recognize this place. This is London. And if you've ever been to London, you may have had some difficulty moving around the city. It has a very complicated grid, but one profession in particularly is constantly exposed to the task of having to move around the city. To be a cab in London, you basically have to memorize the layout and the street names of the entire city. Acquiring that knowledge is known as the knowledge, and it takes between 2 and 4 years. So back in 2009, there was a famous experiment called the London Taxi Driver Study, where they see the impacts of building this knowledge on the brain. So what they do is that they get a group of taxis and right when they're beginning to build that knowledge, and they scan their brains with fMRIs. And as they begin to build this cognitive maps of the city, and as they study more and pass the test, they discovered that the area of the brain called the hippocampus had grown enormously for the cabs that actually performed really well on the test. Meaning, the more they moved around and their knowledge of the city grew, the bigger their hippocampus became. That was a significant finding because it meant that one, in adulthood, our brain can change, but two, there's some sort of linkage between memory and place. The brain is changing as a response of your environment. So Sarah Williams Goldham, I'm sorry if I mispronounced her name, Goldhagen, okay, spoke about this study in her interview with a magazine called Common Edge. And she says the fascinating part of this is that the hippocampus is the area of the brain where we consolidate our long-term memories. It controls our spatial navigation and contains what we know as to be the place of recognition neurons and even building neuron recognition neurons. This means, according to her, that you can't develop a long-term memory that doesn't contain something of the place that you were in when you had that experience. So we navigate space using some of the same neural pathways that we use to develop our autobiographical memories. So architecture and the built environment are central to the formation of our identities. That finding gives the building environment a kind of importance and weight that nobody used to think about.
And this interest of the connection between neuroscience and architecture doesn't stop there. There's many different professionals actually working towards this. And what you guys might know, AMFA, founded in 2002, is this organization that aims to join these different worlds and create this bridge between neuroscience and architecture, so researchers and designers can come together and practice this research, finding more about this connection between the built environment and the human brain.
And in case you're interested in learning more about neuroscience applied to architecture, Bob Condia has created an applied neuroscience for architecture essential reader guide, which you can find at AMFA's website. He's an architect and studio critic seeking the consequences of the applied science for architect. So, I mean, some of these books have had some controversial history, but I think it's really important if you're trying to expand your knowledge upon it to know both sides of each story and actually give each of these and the recommended articles a chance.
And if you guys want this list, we can also send in the chat afterwards. And also just interrupting this, if anyone is not in the WhatsApp chat, just send a message and we can send a link for you to join. And we're going to send all the links for the research and different resources that we came across. But back on the topic of this collaboration of amazing professionals doing research and working on this field of architecture and neuroscience, I would like to introduce our guest speaker, who is his name is Lori Crizel. He's right here, and he's the author of the very first book in Brazil about neuroscience applied to architecture, design, and lighting. And he's a member of AMFA as well, and architect. He's an urban designer. He has a master's in environmental comfort. He's a specialist in neuroscience and human behavior. He's a professor of architecture and urbanism courses, professor and coordinator of postgraduate studies in architecture, neuroscience applied to architecture, BEM, design and lighting, as well as international program coordinator of graduate and undergraduate institute IPOG Brazil.
Without further ado, here's the lecture by Lori. And
memory. Hi, my name is Lori Crizel and I'm here to contribute with an initial perspective to the Neural Networks workshop, which will be later presented by Matheus Stancati and Ligia Filgueiras. On the last day of this workshop, we will meet again. Before formally introducing myself, I would like to congratulate the Digital Futures organizers for the brilliant initiative of holding a worldwide event with the great purpose of disseminating knowledge in various areas of architecture. I especially thank Christine Moon for the honor of the invitation and my great friend and researcher Matheus Stancati for proposing this collaboration. Therefore, as previously mentioned, my name is Lori Crizel. I am an architect and urban planner, master in environmental comfort, specialist in neuroscience and human behavior, member of the AMFA Center for Education Latin America, and for almost 20 years I have been dedicating myself to academic life, being professor in undergraduate and postgraduate courses, as well as professional practice in architecture, design and lighting in my own studio. Along this trajectory, I have been organizing academic and professional immersion activities for my students, who have the opportunity to visit some of the most renowned architecture offices in the world, as we can see in this list here, to learn about their design methodologies and ways of thinking about architecture. These experiences also significantly enriched my studies and research. During this whole time, I have always dedicated myself to researching the behavioral, sensory, and cognitive fields with a focus on the relationship between the user and the space. In a very assertive way, we have been following for some time what important authors have proposed essential analysis regarding this relationship between the users and the environment that surrounds them, as well as regarding the elements that compose this environment. Studies grounded in areas such as environmental psychology, Gestalt, cognitive sensory behavioral science, affluent theory, also known as empathy theory, UX design, emotional design, biophilic design, biomimetics, multisensory perception, and others from a similar perspective make a significant contribution to the theme. More recently, and with a focus on scientific responses and analysis to these concepts, we have the rich and engaging field of neuroscience applied to architecture, also mentioned by some authors due to a linguistic agglutination as neuroarchitecture. In this scenario, I dedicate myself to the gratifying challenge of uniting my research, studies, and experience with the work of these brilliant and renowned authors who so richly consolidated this investigative field, writing a book on the subject, which seeks to present part of this great informative compilation and possibilities of design methodological tools. And today, here with you, I want to show you some of these concepts and dynamics. First, it is important to understand, even if in a simplified way, what neuroscience is about. Generally speaking, we can consider neuroscience as the science that studies the nervous system. However, there are numerous fields with which these study dialogues, such as medicine and others that integrate this knowledge, even make links with computer science and mathematical modeling, as its objective is aimed at understanding how neural circuits work, as well as specific properties of neurons, among others. This combination of information begins to bring us greater understanding about how the human brain develops aspects such as awareness, behavior, memory, perception, learning, and countless others. When we realize how vast this group of knowledge is, we understand how areas such as psychology, anthropology, and others of the same investigative nature also end up being directly related to the study of neuroscience. Therefore, when we comprehend a science that is dedicated to the study of working mechanisms of the human brain, comprising, among other things, factors such as perception, memory, and behavior, the relationship that can be established between neuroscience and architecture now seems clear. Let's get to know a little bit more about these multiple relationships. It is essential to understand that this workshop will work on the relationship between neuroscience and architecture, reaching the point of using neural networks as project dynamics. Therefore, it is possible to comprehend how these two fields of study are organized together. I would like to start our dialogue by formulating a collaborative idea to better understand how the topic of applied neuroscience reaches the scope of architecture, bringing along its contributions. So, let's start with the journey that psychology and architecture have been building for a long time. Within the universe of psychology, there is an area called existential psychology, which approaches philosophical assumptions along with psychological principles. This approach studies how philosophical issues can affect the psyche and human behavior, influencing decision-making and the structure of relational forms. We realize now that this is an extremely significant area of knowledge for our investigation, as behavior, decision-making, and relational mode are precisely the assumptions that we seek to understand and analyze in the interaction between user and environment. This approach to psychology is also anchored in neuroscientific assumptions, presenting the configuration of certain relational fields, In general, and brought here in a purely methodological way, we can mention the sensory, cognitive, and behavioral fields. Understanding the relationships and intersections between these fields is of great importance for us to have a more holistic vision at the human psyche and its relational mode with the space, a field that neuroscience applied to architecture seeks to investigate. In a simplified way, and focus only on the field of architecture, we could consider that the sensory field is where our perceptions of the external world occur, that is, through it, we receive information from our sensory neurons. We can think at the first moment about our senses of sight, smell, taste, hearing, and touch. However, neuroscience already presents a range of other sensory systems. The cognitive field is where our interpretations occur according to what we perceive from the external world, as our cognition is associated with our ability to acquire knowledge through processes such as perception, attention, association, memory, language, learning, reasoning, among others. Thus, in the cognitive field, we use our baggage of personal experiences to translate what we perceive of the world and thus are able to give meaning to what we perceive in the sensory field. It is worth mentioning here the brilliant work of Dr. David Kirsch, renowned researcher in the field of cognitive science and architecture, currently President of ANFA, Academy of Neuroscience for Architecture, and he will be with us in the last day of this workshop to discuss the theme. The behavioral field is where the meaning that was assigned in the cognitive field to a given sensation is translated into a behavior. In behavioral and cognitive behavioral psychology, human behavior is analyzed through scientific methods in relation to the factors that influence the way you are feeling, acting, thinking, etc. Understanding this simplified methodological model of the fields presented, we can see that, through this perspective, a given sensation is perceived in the sensory field, translated into the cognitive field giving a meaning according to the trajectory of personal experiences, culminating in a response expressed in the behavioral field in relation to the previous relationships. We realize that architecture, from the moment it proposes spatiality which will be experienced by a user, will result in the relationship established by the sensory, cognitive, and behavioral fields. Thus, we have the link between architecture, which proposes built environments, existential psychology, which addresses the intrinsic relationships in this specific scenario to behavior, and neuroscience, which brings the investigative field in the physiological scope. As architecture has always been dedicated and continues to dedicate itself to generate positive and meaningful experiences for its users, understanding the relationship established here and their scientific analysis becomes an important tool in the design field. The item meaning, linked to identity development, ends up establishing social relationships through certain spatialities, also known through the concepts of first place, normally used to mention residential spaces, second place, normally used to mention workspaces, and third place, normally used to mention social spaces distinct from the first two, which present a significant experience capable of being relevant to the user. When we understand that anthropology is dedicated to study human being and humanity in its broadest sense, considering therefore other dimensions such as origins, beliefs, social habits, physical, social and cultural development, among others, it can be seen that anthropology encompasses issues also linked to philosophy, psychology and physiology, areas that we have already covered. And why is anthropology invited to participate in the relationship between neuroscience and architecture? For a very specific reason. The human being cannot be reduced to a single comprehensive structure. We are beings endowed with countless skills. Thus, anthropology, being the area that comprises the human in its entirety, including its most varied relational forms, psychological and physiological aspects, help us to structure a symbolic understanding of the user to whom a given architecture is proposed, thus resulting into a greater possibility of creating a meaningful relationship between that user and the built environment. Return to the fields of anthropology and psychology, we can mention the universe of phenomenology, a field of philosophical study that deals with the structures of experience and consciousness, adopting the assumption that knowledge is based on how our consciousness interprets the phenomena. In other words, by joining this knowledge to the assumptions that dealt with anthropology and the fields of existential psychology, we have another important tool in understanding the user-space relationship. Phenomenology presents us with the terms noesis and noema, which establish our relationships, with noesis being an intentional act of consciousness regarding the subject's willingness to see a given object, a real content, and noema, what is seen by this same subject as thought, judgment, or perception, an ideal content. In parallel, in the universe of architecture, we have long used terms such as symbol and sign, with symbol being the real, visual, and graphic element that symbolizes something, and sign being the meaning we adopt in relation to what was expressed by a given symbol. In other words, phenomenology was intrinsically part of thinking about architecture in view of the relational assumptions that it was intended to generate with the users of that speciality. These correlations configure a new universe in the field of architecture. The neuroscience applied to these research studies comes to significantly help in the understanding of assumptions from measurements that configure a new investigative frontier. Throughout this workshop, Matheus and Ligia will present a fascinating study that addresses, among other issues, neural networks that relate what we see and how we interpret the visualized object based on our memories and preconceived ideas, that is, noesis and noema, symbol and sign, and thus it becomes possible to create, as Matheus used to say, parallel variations of my reality in a network that I can access, browse, and explore. From the topics discussed so far, it is already possible to understand many points that structure a relationship between user and space through the meaning given to this experience. It is precisely the meaning of this experience that will connote the emotional valence that we will give it. The concept of emotional valence indicates the affective quality that we will give to a personal experience, in general terms, whether good or bad. Given the aspect of qualifying a given experience, here focused on the universe of architecture and its relationship with users, we understand that once this experience results in an emotional valence of a certain intensity, we tend to remember aspects of this experience more easily. We start talking about affective or emotional memory. The term affective or emotional memory is normally used when a given experience was able to produce a certain emotional reaction and, therefore, facilitate its recall, encompassing important aspects and characteristics of that experience. If we bring this reasoning to architecture, it is easy to understand why we tend to remember more easily spaces that were significant to us for some reason, but we don't necessarily remember with the same ease all the spaces we've visited throughout our existence. In other words, environments that provide us with experiences of emotional valence capable of generating affective memory are more present in our records. So, I leave the suggestion to investigate assumptions that can greatly contribute to the organization of a given experience, the concepts of emotional design and affordance. Briefly speaking, we can say that emotional design seeks to offer a positive experience to the user for features that stimulate certain emotional reactions. Affordance refers to the ease with which users recognize attributions of a given object, according to how it presents itself to that user. For further investigation into these two concepts, I strongly recommend the work of the renowned author Donald Norman. From the concepts worked so far, we can then begin to enter more and more into the universe that encompasses the use of neuroscience in architecture. I invite you to talk a little about it. As everyone here is a lover of architecture, I will begin our dialogue using the statement made by the famous German poet Johann Wolfgang von Goethe: "I call architecture frozen music." very likely Goethe, with his sensitivity, tried to translate into this statement how the experience lived through architecture resembles that lived through music, which tends to sensitize us emotionally and may even trigger us certain memories. Thus, if we restart from the observatory assumption that the environment in which we are inserted, with its materiality, composition, organization, and sensorialities, visual, olfactory, tactile, auditory, among others, as well as its link or lack of with records of memory, can play a relevant role in the way we relate to this spatiality, in the way we can develop certain sensations, behaviors, and even in the way we develop our routines, the way we use this space, and sometimes we even configure an identity relationship with it. In recent years, neuroscientists, often in collaborative partnership with specialists in psychology, have been dedicated to measuring how a given group of users physiologically reacts to a given environment, whether internal or external, using as methodologies the use of specific equipment for these measurements such as electroencephalogram, which records brain data and enable the analysis of greater or lesser activation of certain areas of the brain, biosensors used to monitor data such as heart and respiratory rate, temperature, sweating, among others, use of eye tracking technology, which allows to analyze the user's visual attention, being possible to determine in which region his attention is more fixed, for how long, the eye movement sequence, reaching the possibility of evaluating the dilation of the pupils. These are just some of the many technologies that exist today for the use of biosensors. Some of these technologies you can see being used here throughout the work that Matheus and Ligia will present. From this data collection and interpretation, it is possible to carry out an investigation on how the study participants reacted, physically and mentally, to the stimuli proposed by the environment: excitability, whiteness, coziness, discomfort, security, insecurity, etc. That is, how the sensory, physiological, and perceptual connection between the user and that study environment occurred. Oshin Vartanian, professor in the Department of Psychology at the University of Toronto, Canada, explains in his research that a set of structures in the brain involved in experiencing emotion and rewards are also activated when we feel pleasure in architecture. In this same investigative scope, renowned authors and researchers have been publishing brilliant works uniting several themes with significant relevance for the study of neuroscience applied to architecture. Here, I mentioned some of these authors, but others have also been standing out in this scenario. Just as psychology has already been dedicating itself to the understanding of human behavior in face of certain specialties, the so-called environmental psychology, neuroscience presents scientific conditions that measure specific physiological data regarding this experience. For this reason, I invite you to take a brief look at the context surrounding the knowledge of how the human brain works and architecture. As I mentioned at the beginning of our dialogue, in order for us to reach a greater understanding of the importance of neuroscience for architecture, we would need a quick understanding of some issues that precede the scientific question of the subject. So, we've talked so far about the relationship between the user and the environment, existential psychology and its approach to sensory, cognitive, behavioral fields, anthropology and its considerations about the different dimensions of the human being, phenomenology, uniting philosophical and psychological concepts, noesis, noema, sign, symbol, affective memory and its relationship with a given experience, and then a link between neuroscience and architecture. Very well, from that moment on, we will dive a little more into the universe of neuroscience to verify important considerations and their scope regarding architecture. Let's always keep in mind that when we talk about neuroscience, we are talking about a scientific study based on evidence, measurements, analysis. Before departing for this scientific dialogue, I reinforced the indication of important readings of neuroscience inserted in the universe of architecture. Let's recall the list of authors already nominated. In this same sense, for research more directed towards understanding the neuroscience and the structures of the human brain, I strongly recommend a constant visit to the following websites: Society for Neuroscience and Brain Facts, a platform maintained by Society for Neuroscience. Very well. As the role of this dialogue is just to present how neuroscience becomes relevant in the universe of architecture, I will only expose a single point of research that will be enough to understand this importance. So, we are going to use a 3D model of the human brain available on brainfacts.org from Society for Neuroscience. Given all this universe of possibilities, I will only use the limbic system for this quick invitation to further investigation. According to what is presented by Brain Facts, the limbic system is a large group of brain structures responsible for motivation, emotion, learning, and memory. Belonging to the limbic system, we have the hippocampus. Again, following what's presented by Brain Facts, the hippocampus is responsible for short and long-term memories. It also creates mental maps of places, which make it easy to navigate in a complex environment. This is known as a spatial memory. Good. We realized that in a quick analysis of a single brain region, the hippocampus, is capable of managing our memories as well as helping us to create mental maps of the environments we often visit. Everything we've talked about so far has been based on how architecture could promote meaningful experiences to the point of generating affective memories. If only the superficial understanding of aspects of the hippocampus already show us a single brain structure which deals with spatial mapping and memories, we can see how architecture can benefit from this more in-depth scientific study. Resuming an initial approach to our dialogue, other studies greatly contribute to this generation of experiences in architecture, such as environmental psychology, Gestalt, cognitive science, influence theory, emotional design, biophilic design, among others. However, the scientific knowledge of understanding the working mechanisms of the human brain is essential in this new look at architecture. Obviously, now a new journey of study begins for all of us. Matheus and Ligia will now talk about how the understanding of these mechanisms combined with neural network methods and technologies can be used in the generation of experiences. Thank you very much for your attention. I really hope you had good insights with our dialogue. A big hug and see you very soon at our meeting on the last day for a discussion on the topic. Meet you there.
Well, thank you very much, Lori, for this conversation. It was so insightful, and it's always amazing to have you here. You sharing a bit of the vast amount of knowledge that we know you have. Carrying on, just like Lori said. Okay. This idea of taking this emerging technology and proposing different ways of experiencing, architecture, and as well as, this future possibilities of what architecture entails with this knowledge of neuroscience. One of the different frontiers of neuroscience applied to architecture, as a term that Michael Arbib uses, for example, is neuromorphic design, meaning that architecture, what if the building actually carries a brain, and the building is able to make decisions or collect and process data from its users and the environment, and then change itself more accordingly.
So now we're going to cover a couple of case studies where this kind of technology is being explored and these ideas are being questioned, not only in architecture, but in the art world, in the fashion world, in the academic world. So many of you probably know Replicano. He works in the fields of site-specific public art with parametric data sculpture and live audio-visual performance with immersive installation approach. Particularly, his works explore the space among digital and physical entities by creating a hybrid relationship between architecture and media arts with machine intelligence. His works begin to blur the boundaries between what is and what is not physical space.
By a 6th dimension, X, Y, Z, and RGB. And then finally, we said that if a building can dream, like how would do that? So if I was a building and have an AI capacity, I would go online and download every single image that people shooting me. and basically, we download every single image of Disney Hall that we could find and train neural network, PG again, and let the building understand its potential, kind of, like the selfie of the building, and let the AI take over the surface, the skin of the building, and transform the building into 3-dimensional surfaces. So what you are watching, 2 years ago, maybe now it's old, but it's still a fresh idea in my mind that the building has this capacity of like dreaming and speculating its own form, like judging itself, like why do I need to look like this? Like what makes me this titanium? Like why am I in this form? Anyway, so at the end we made Disney Hall Dreams 2018, and thanks to Frank Gehry and LA Philharmonic and City of Los Angeles, the project I think was one of the most welcomed public art piece in Los Angeles. There was an enormous team, not a lone piece, but happy to say that the 3D transformation of making the buildings like disappear, appear, and most importantly, I think people's reaction, like they become a part of the experience. So architecture is not anymore alone, dark in the late night, but has an inside outside, like materialization, parametricism, and machine intelligence, music, and a science fiction, I guess, right? The home of, many movies, was really inspiring. And Alejandro Inharito was one of the our gala guests, and he was saying, it's the first time I was feeling that I can touch a science fiction. It was an incredible feedback because, Frank Gehry he was very happy because he said, oh, they said it's not possible. They said it's not possible to project because it's a reflective surface. So we already skipped that part. He was already dreaming a building in downtown. But it was an incredible night. I wish every architect like Frank Gehry, every city like Los Angeles, every institution like LA Philharmonic allows people like me to come and encounter their dreams. And I think it's a kind of a speculation, I guess.
And just to coming back, the project by Rafik is absolutely brilliant. And some other projects thinking about this idea of the building having a brain is the project called Orbis. And it was presented a couple of months ago in Digital Futures. And the idea is to create this building that is made of modules. And these modules, they communicate with each other and they're able to move around, connect with themselves and generate structures based on what the inhabitants need. And, collecting data from the environment, communicating and making decisions, making these, almost like a swarm of robots constructing the built environment. And we also got a little clip of the presentation because we can talk, but nothing better than the original source. So
we knew that in order to address the future of culture, architecture needed to be explored through a lens that looked beyond static and conventional systems of infrastructure. Deep embedded principles of natural systems that are highly intelligent and behavior-driven provided us with great opportunity to learn and realize that architecture can offer something derived from life itself. Which led us to wonder what our future culture could look like. We then started our research to devise an agency in which humans and robots are interwoven, a system that would imbibe principles of mobility, intelligence, and self-assembly, and the idea of what the future of cultural spaces holds coaxes us to move beyond form and its redundancy.
Through our various iterations in developing a unit, we studied behaviors of packing, transformation, and flexibility in the connections and different patterns. Investigating this, we decided that a sphere is probably the best option as it combines the ease of mobility, symmetricity, and a compact packing ability being the few key features. The optimal unit would be achieved by giving the sphere 6 connection points on the 3 axial directions. This would aid it in connecting with other units and climbing up to the next layer. We also explored angle connections that were generated by a slight rotation of the leg of the connecting leg. This would aid it in forming a triangle and a pyramid based on which we ran multiple simulations and research. Our research also explores different connection options based on the number of connecting units.
Among the several tests that we conducted, the most common patterns were based on pyramids, triangles, and squares for each system.
But then you can see how these different modules can then form all sorts of structure and be part of this interaction between humans and the built
insights of the
environment.
various responses we received.
Another project. You go ahead.
Another great project that we would like to present is The Caress of the Gaze by Benas Fahadi. It is an interactive 3D printed wearable which can detect other people's gaze and respond accordingly with lifelike behavior. She posed the question, what if our clothing could behave as an artificial skin capable of changing its shape and operating as an interface with the world, defining social issues such as intimacy, gender, and personal identities. And when you watch this video now, I would like to also pose the question, what if similar concepts like this were applied to buildings? What if the buildings that we have in the future could somehow behave in the way that we do and have this direct connection to the or eye tracking movements or facial expressions or so on.
All right. Amazing. And okay, so carrying on, this is if you're researching and looking at neuroscience and this upcoming technologies going on, you might have heard about Neuralink. And because its founder and the actual person behind it is Elon Musk, he got a lot of attention from the public that is watching closely what happens. So we're going to talk a little bit about it. And Neuralink's idea is to implement a chip in the brain. So it's in a way an invasive piece of technology, but it's proposed to be a brain-computer interface that can then communicate to the different parts of the brain, such as the visual cortex, the auditory cortex, the somatosensory cortex, and motor cortex, and then create this bridge between brain and artificial intelligence, meaning that you can then communicate with computers and for example, in the website, they even pose the question, but if you can type, message, you don't need to use your thumbs. And the whole idea that, Elon has talked about in interviews and, the idea of the company is communication. Let's talk about communication, for example. I am right now, I'm thinking about something. My brain is processing information to deliver to you guys. So as soon as I think of something, I then have to send this information for my throat is regulating the air coming out and creating sound that transmits into this computer. Then computer sends via Zoom and internet it to your computer, and then it creates its own sound. to then your ears receive those sounds, and your brain finally takes the actual data and converts it into information that it can perceive and understand. And in a way, the information is coming from my brain to your brain, but it has so many layers of energy consuming techniques that we developed through evolution, etc. And Neuralink is trying to say, okay, what if, because we evolved and we are creating our own evolution with technology, what if we can communicate brain to brain, or brain computer brain, and in a way, you know, cut or create a shortcut, let's say, between communication, which is extremely interesting, and then raises the question as well, okay, what is the future of architecture if I don't need to regulate, walk to the thermostat, read what the number is on the temperature of the room, and, you know, regulate temperature, etc. What if me and building becomes, you know, this communication aided by technology? And this is a video that got a lot of hype recently, which is they used the testing of Neuralink to create this interface between a monkey's motor cortex and a video game, meaning that, you know, even though the monkey doesn't know that it's doing it, he's able to control the video game up and down based on what his brain is processing as motor signals that would control his arm. And the interesting thing is that this looks like just a joystick, but it's not really connected to anything, meaning that as he moves up and down, the Neuralink that he has implanted in his brain is picking up on the signals for motor, and you're able to get real life data from, you know, what's happening in the motor cortex. And then this is just the start of something, and there are even videos explaining this and talking that, okay, this is impressive, this is really nice research, but at the same time, there are so many other people behind this that have been doing tests with this since like the 70s. And, you know, it's not that Neuralink is, you know, absolutely the owner of neuroscientific research. There's so many people behind this as well. And then this next part is, we're going to take a different, you know, step and talk about, okay, if there is a connection between the human brain and architecture, how would be a way of measuring this or understanding or creating a study? And to understand this connection, let's say that we're trying to prove the truth of this connection by correlating different aspects of architecture and different aspects of what's happening in the human body, and then comparing this data to then find the moments of commonality and this intersection, you know, of what in architecture creates this and what in the human body could inform architecture. So now I'm going to answer the question actually that no one asked me, because I'm the one creating the slides.
I can ask them.
And the question is, if I had access to a time machine and unlimited resources, what building would I use as a subject to study neuroscience applied to architecture? And the answer that I would probably give to this question, if someone would ask me, is actually in 1851. And you might be thinking like, what? That's so long ago. And you might be able to recognize the city because of the river and the famous bridges and the parks. And the building that I'm talking about is right here. And if you studied architecture, there's a huge chance you know it. And even if you didn't, because this is a famous building, this is the Crystal Palace. And the reason why I would choose the Crystal Palace, you're gonna find out, even if you don't understand, you know, how obvious this is to me. And we're gonna dissect the history and elements of the Crystal Palace, creating a hypothetical study, a hypothetical neuroscientific exploration to try to create this link between what happens in the human body and what happens in architecture. If I had a time machine and unlimited resources, I would do. So a good introduction to what the Crystal Palace was actually done by Professor Michael Hayes and Antoine Picon from Harvard. And they explained that few buildings have made such important movement in architecture history as much as the Crystal Palace did. And not only was like a different way of building, a different, technique being used that no one had ever seen before, but also the actual usage of it. It hosted the very first World Fair and for the Great Exhibition, and it created a new type of space, a new species of space, let's say. And the revolutionary nature of the building was immediately felt by the contemporaries at the time. Not only was immense, but it also introduced the public to a new realm of merchandise and catalysts and products and a world full of wonders. And the interesting thing is that some writers at the time, some critics actually wrote that the building seemed as large as the entire planet. So talking about this brief history class of the Crystal Palace, I just want to point out that I'm by no means giving as much of a good lecture as Professor David Rifkind would, or Antoine Picon, but I'm going to try my best. And I had the immense pleasure of having, learning about this building from Professor David Rifkind, who is a brilliant historian and researcher. So the idea of exposing technology at the time was not necessarily new when the Crystal Palace was created. Back in the 18th century, there was already this, conversation about exposing technology, and there is the encyclopedia of Diderot and D'Alembert, which was this manual or this encyclopedia. Encyclopedia. I'm so sorry. That exposed all sorts of technology at the time, and the term industry was actually understood differently. It didn't mean only machines and factories, but industry meant everything that is productive to human beings. And you're going to see even the very last, exhibition or sort of space devoted for technology before the Crystal Palace even included cows and cattle alongside with machines as part of technology, as part of, what's productive to human beings. But then the idea for the Crystal Palace came because of the protagonist on this picture, Prince Albert, who he became the president of the Royal Science Society of Arts, and they wanted to do this massive installation, this massive exhibition to showcase what England had so great, but also to get, expose what's happening all over the world. And then the person, Joseph Paxton, you're going to see was the actual mind behind the construction of the building. So as soon as they decided this, they were able to secure a loan to a piece of Hyde Park, about like 800,000 square feet land that it would need for the exhibition. So they opened a call of proposals for a competition, one of the biggest, architecture competitions at the time. And they issued the competition in March of 1850. And in a couple of months, they got 250 submissions from the UK and France and some other parts of the world. And out of this 250, two got the most recognition at the time. One from Hector Houreau, who proposed something that described almost like a big shack. And the other proposal that got a lot of attention was from Richard Turner, who is an engineer and who was an engineer and had recently done a greenhouse with this new technology of cast iron and all. But they realized that perhaps the best thing to do was actually a large building, one single building instead of separate ones that would house all the artifacts that they wanted to exhibit. And no proposal actually met the criteria. So Prince Albert was basically like, nah, we got this, even though we don't know exactly what he said, but that's what he meant. And they started actually their own architects and engineers from the committee started working on the building that we built. And this was the result of what they were making by themselves, which is not only horrendous, but people did not agree with this. It started getting posted on journals and newspapers, and the public was not happy. And that is not the only thing, the disapproval from the public, but also this is a temporary structure that is done for a temporary, installation, and it's all made of bricks.
This reads as temporary.
Exactly, no, not at all. And they're all like massive blocks of bricks and stone that, the amount of energy and time put into this. But anyways, and then comes Joseph Paxton into the picture. And he comes as a superhero because Joseph Paxton, he wasn't an architect, he wasn't an engineer, and even Queen Victoria at the time refers to him as a gardener. And he was indeed the chief gardener at the Duke of Charlesworth, I want to say. So he, the Duke actually commissioned an expedition to bring a bunch of tropical plants into England and acclimate them in his property. And then Paxton saw that as an opportunity for him to explore and he created this huge greenhouse that they called the Great Stove. And then another project that really influenced the Crystal Palace was the Lily House, which was a building done with, it was a different way of doing the beam system and the actual roofing that made this very large span happen with very thin materials. And the Lily House housed, large Victoria Regia plants, which are the giant lilies. And then they invited Paxton, seeing all of this, to participate in the construction of what would then be the Crystal Palace. But the submissions had already passed and no one could submit anything. But they had this little regulation kind of hidden in the regulations for the submission that if someone proposed a building that would be cheaper and faster, sure, they could consider. And then Paxton did the very famous sketch that is this. And you can see here how this relates to the roof of the Lily House. And it's a very modular system. The whole idea for making this cheaper is actually create a 24-foot grid that would make this very modular. And then they said, sure, let's go. And they started constructing. And this ended up being 60 to 80% cheaper, more seductive and flexible because of the modularity. And I could talk for a long time about the actual construction, but what is important to know is this modularity and this continuity. And this whole set of different technologies that were used at the time, that were used for the Crystal Palace, that were by no means used before. Even the whole management of water, the hollow columns that would, take the rain out of the building, and etc. But okay, the construction is not the most important thing. What is important to know is that this was the first building that encompassed the sense of eternity. It was the type of building that you would look down and not see the end, and you would just feel like it would never end. And also the idea that because it was the great exhibition, exhibiting pieces from all over the world, people were talking about this idea, even this caricature at the time, that it was a building that housed the entire world. So why use this for a piece of architecture, a piece of studies of neuroscience and architecture? And it's not necessarily because of how the building looks here, it's because of how the building looked then. And that is the part that is interesting studying. There's so much richness into the different elements that make this building and the amount of people and all, which we're going to talk about, that just take a second to look at this. It's a remarkable piece of history. So, okay, measuring the Crystal Palace and the impacts that it had on the brain. And this is Queen Victoria with a helmet from Colonel, but that's not what I mean. It's let's dissect this into parts. So back to that diagram explaining the human brain and architecture, and to measure the connection, one method of actually collecting this data would be something that is known as voxelizing, meaning that you would take the volume of the building, the volume of this interior, and overlay a grid over it that you can measure each voxel of the system, and then individually, and then create this map of the data that is being collected. And because of what I mentioned, the actual structure of it, it was planned to be a modular system. You can account that each of these modules would be the same, around the same size and the same general structure, because of the overlaying structure of the building. But at the same time, it was filled differently throughout the building. So you have different elements to measure that we're going to talk about. And then again, as people walk through the space, you can then measure each of these voxels as an individual thing and as a collective thing. The voxels around it, where the person is, even though there's not an immediate connection, there is the visual connection and the auditory sounds that are around. And you could then overlay this grid of hierarchy between the data that should be used and the importance of the data from the different voxels. So now looking at the, here the orange voxel being where a person would be, and the gray around being this, let's call it this proximity voxels. We can then enlarge this to showcase, okay, there is a certain area to be studied, and there is some sort of, proximity voxels to take into consideration. But then we should measure two different things. One is measuring the data from the environment, which, is whatever information is inside that little space. And then the other thing is measuring the data from the human and what is actually happening to the person inside that space and the connection with the elements around. So if we're going to take the voxel metrics for an environmental data, we can then talk about light, how bright the space is, how the shadows work. And in this case, it's needless to say that the Crystal Palace was crystal transparent. There is actually a lot of, penetration of daylight and the whole idea of circadian light being exposed into the building. So throughout the day, the lighting plays a different role on how the building works dynamically in terms of lighting, as well as close as you are to the boundaries of the building, the more access to daylight you have. And then when you're down on the base floor underneath all the stairs, complete with like rugs and different types of fabric, you can find yourself in dark spaces. So each of these voxels could have a means of collecting information about light. And then that's one of the elements to be captured from the environment. Another thing is interior volume and geometry. The difference in ceiling heights and the actual geometry of the pieces in there. So if we're separating this into a couple of sections, some of these spaces, they have one story, let's call it one story. It was much higher, but one story, double height stories, huge barrel vaults. And the barrel vault was created to house the plants, the trees that were present in the park. But and then you can then study, attach this piece of information. All of this goes into information collected in one voxel. And the importance of this ceiling height, there's many researches about the different shapes and geometry of spaces. And this one is very interesting that it was performed. It was a collaboration of a couple of universities, and the name is here. And I will send a link to if anyone wants this resource. But this was a study done that they modeled in 3D many different types of architectural spaces. And then some subjects actually experienced the spaces in virtual reality. And they used EEG scans to actually map different responses on the brain depending on architectural shape. And this is the idea of the different levels of spaces in the Crystal Palace in terms of geometry could have been used if I had a time machine. And you can see, from a huge open space with a lot of light to like some of these spaces back here, that would be way lower, more confined, way less light, etc. And then you see, for example, this pavilion inside the Crystal Palace that is completely different than outside. And then throughout this building, the internationality of it, you have different cultures and shapes and understanding space that could all be taken into consideration to measuring one voxel.
Yeah, even the lighting in that one image.
Exactly, the lighting and the materiality also. Because one thing is talking to someone in that huge space, the other thing is being surrounded by fabric. And remember that this was also exposing technology and machines. So talking next to a lot of metal and talking next to a lot of fabric has a different, it plays a different role in the acoustics and the color, the way you perceive the space, how light reflects. And these could all be, again, data measured into the environmental factors of each voxel. Again, biophilia, which because this was a loan, they actually rented a piece of the Hyde Park they had to return Hyde Park the way they found it. So they actually made the barrel vault that was not intended in the initial design just to house the vegetation that was already present. And, and then you can then use this piece that was embedded into the architecture as part of the studies. How do people feel when they're closer to nature than they are confined in, man-made structures? Can you then map, the difference between how people are in those spaces? And then another thing, temperature and humidity. And this is actually, we take for granted now with technology and AC and all, but the building was a large greenhouse, meaning that even in London, that is not the hottest place in the world, it would get really hot. So they actually designed a way of escaping hot air and all within the roof system. But throughout the day, the temperature changes. And then when the temperature changes, does it have an effect on how people behave? This, again, all taken into the information in one single box. Aromas. This was an international exhibition with products and fabrics and, different elements from many different countries. If you are passing through the Indian pavilion and experiencing the spices, and then you go into machines that have oil, all of these different aromas also play a part in each of these blocks. So, again, and also people. Remember that there was no deodorant back then. And then ambient sounds, sounds of machine compared to sounds of people, and being surrounded by fabric or metal, etc.
And also just overall, how these all relate to each other and overlap each other, like going back to the materials with the sound, with the fabric, with the sun, how is that going to change one voxel also at different periods throughout the day?
Mm-hmm.
The same area could have a completely different experience within 12 hours.
Yeah. In the morning, the same spot with the same lighting, with the same materiality, with the same artifacts around might have a different scent in the afternoon. At the same time, something that has the same scent here might have a different lighting or a different, all of these change. And this is the beauty of, if I had unlimited resources, you can have sensors in each of these boxes, which we're going to talk about, and actually measure all of this data into a huge map, and then make the relationships a correlation. But anyways, carrying on, if these are all the information collected about the environment, and these are just some, there are way more if you actually get deeper into it. This is just an exploration and showcase. But now, what about measuring the information and data from people inside this voxel? One thing is a psychometric analysis, which it's based on a questionnaire, asking questions and subjective, response to different questions that could be taken in the actual opening. Let's say as people are walking in, they just have to fill in the blank.
And because the Crystal Palace had people from all over the world, this could be, if there's just a general questionnaire about very specific things, you could gather an insane amount of data about these things.
Yeah, almost like a preliminary data that could be associated with each of the personas, registered. Another thing is focus point, how people, as their experiences different spaces, what are they looking at? What is the pattern of visual, tracking? And there are some studies that look, using technology that are, focused on vision tracking and eye tracking. They are then focused on what is the pattern? What do I look at first? What do I look at last? What am I looking at the most? What actually attracts me? What doesn't? So then, you're going to see this starts correlating all of the elements that we're, collecting, all the data we're collecting from the environment with the response of the human, what actually works, what doesn't. Another thing is the mood status. How do people feel when they are in that specific voxel, or when they do this, voxel A, B, and C in a row? What if they're going the other way? And one way of measuring this would be facial recognition. If I can, fit some cameras in my time machine, actually recording facial expressions and, running algorithms that are able to tell emotions from them. And just to give an example, this is a open source, well, you can do a demo of this algorithm and machine learning piece of technology that just from recording your face, you're able to track all of these different emotions as well as different features. It was able to tell that I had a beard, a goatee, your level of focus, if you're paying attention or not, all of that from image, like 2D image. Another thing is physiological data. So all of the information about the actual body, how my body's working. And one of the big things is heart rate variability, which you can look at research, and I can share some of the research that I came across, but how the heart rate variability, which is different than heart rate, is actually the distance between each of the heartbeats analyzed as a whole, can actually tell if I'm being appreciative or if I'm being annoyed, and how, in a way, it's your heart telling what is happening in your brain in a way, or other things like body temperature, which can tell a lot about comfort and thermal comfort in the space. Another thing, EEG signals, which can then map what are the areas of activation in these different parts. And I put this image here to show, okay, they would be extremely uncomfortable with this piece of technology in 1851, so we could hide it within a top hat and just tell them that it's a free hat. But with EEG, could we then map which areas are being activated, what are they using those specific boxes? Another thing, and I think this is the most important thing about the Crystal Palace being used as this hypothetical neuroscientific study, which is the amount of people present there. In the couple of months that the Crystal Palace was exhibiting, they had over 3 million people visiting the space, which would be a huge amount of data. And not only that, different studies. This is just an example from one research paper. And most research papers collecting data, they will say how many participants, age, sex, men, women, and some other, data about those people. And the thing that is really interesting about the Crystal Palace is that it took many different people from many different classes, age, etc. Here on the top, you can see Prince Albert and Queen Victoria alongside all of the nobles and the high elite of England. And at the same time, every couple of weeks, they started selling tickets to other classes. And at the end, you had all the workers, all of the quote unquote, let's say almost marginalized people at the time that also got to experience the same space. So at the same time that you're collecting all of this information, you're also collecting for different type of people that would be interested in different things, different ages, different body shape, and health levels and all. And with all of this information, imagine we could put together a 3-dimensional map that would be X, Y, and Z with a location, and many other dimensions that actually go with the actual data collected then. And the interesting thing is it's not only X, Y, and Z, but there's also the 4th dimension to be measured, which is time, the period throughout the day. And just an example, I did not do a 4-dimensional map of the Crystal Palace, but this is something that I've worked on before when I was studying for my thesis. And this is a 2D map or diagram of what it takes to get out of my room in Doral, Miami, in Florida, walk down the stairs, walk out of the house, get on the car, and these are the turns that I need to take to get into the highway, get the exit, get into my university at FIU, get onto the parking garage, go up the parking garage, park the car, take the elevator, walk across the street, and walk around the building of the School of Architecture, walk into the building and sit at my studio desk. So this is a 2-dimensional map representing space, so X, Y representing space. So if I want to represent time as well, in the X direction, this is just me rotating it 45 degrees so I can draw an axonometric. And in this case, as I'm walking through my house, I'm going through these different layers in time, which means that the map is not from here on the top. When I leave my room, I could never experience what studio is like at the same time. And as I'm going through the space, I'm also going through time. And this is the idea of what we could do to actually connect the data with a different time. to map out human interaction and architecture in 4 dimensions, which is interesting. And there's this article published in 2020, which, if you're interested in this area, is extremely interesting. I'm not going to get super into it, but it talks about the mathematical basis for doing a spatial temporal framework in 4D, with this idea that there is a space, a three-dimensional space, and this difference in time and how to represent it. So this is this assignment of, what to do with the Crystal Palace, and, a building that could offer to us access to very, very crucial and important information about the relationship between humans and architecture. So
for the assignment, remember all the parameters that Matheus just talked about, right? All the environmental data and all your physical data, and how that could be utilized towards something together, how those components could overlap and correlate, and what kind of data or information you could derive from that.
So yeah, we're giving you an assignment, which is it's okay. Don't worry. It's not hard at all. But in this example, the Crystal Palace, we're seeing the building that we proposed, year build, architect, the program function, and then what we measure there. And what we want from you is to think and actually do this. If you have access to Adobe Acrobat, you're able to just place an image, or Illustrator. We're going to provide all the files and send tonight the link to a Google Drive for you to get the file and submit your idea. But because this is Inclusive Futures, we were thinking perhaps it would be interesting if you can think of a building in the country you're from, or try to choose a building, and it could be anything, a shopping mall or Art Basel, anything, but then we will all have access to these different potential places of exploration to study neuroscience and architecture.
Yeah, and this is not supposed to be a hard assignment at all. It's really just like thinking back about what you just saw in the presentation. Basically, what is a place that you find interesting, that you think different kind of relationships could happen throughout the day, that different kind of relationships could happen in different areas of the place, in, I don't know, the way people perceive each other, what type of people frequent this space. There's unlimited amount of things that you could dive upon, and it's really not supposed to be stressful at all. It's just, think about somewhere that intrigues you, somewhere that maybe you've experienced a lot growing up, or maybe it's meaningful to you now. And how would you go about measuring the data of this space and the way people perceive this space? And what do you think you could get from that? We're trying to open up a discussion, like a conversation. So really feel free to choose something that just intrigues you.
Mm-hmm. And then tomorrow, what we're going to do is go over these submissions, just like as a, talking about it and exposing it to everyone. And what we're actually going to talk tomorrow in the workshop is the same idea that the Crystal Palace had all of these different elements to be studied. How can artificial intelligence help us or become a tool for us to create spaces to then analyze human response? And we're going to go into this tomorrow on a live demonstration on how to get what I'm about to show. And these are images of spaces that do not exist. So what we're going to try to do is think together, how can we then, generate these images, or that, we're going to show, but there's actually research and exploration with 3-dimensional generations as well. And what you're going to be able to do tomorrow is transform language, semantics, how you actually can describe a space into images that could be used as a tool to then create unlimited variations of Crystal Palace, unlimited variations of an architectural space that you could then measure. What is the human response inside that? At least from a visual perception point of view, or a spatial perception. So this, for example, is a building, the prompt or the actual directions for the neural network to produce this was a building filled with plants. And in this case, you can see all the variations, but they all follow the same theme or the same general instructions. And in this case, the direction and the prompt was a building made of gold. And perhaps we're not there yet in civilization or technology that, oh my God, this looks like a real building and it looks like it can go in right now. But it's still enough that we can perceive that that's a window. That's where the floor ends. That's when, you know, that might be a street. It's outside looking at the building. That's a facade. And that could be enough to start thinking about how can we use this then to measure human responses and then create unlimited amounts of data, literally crystal palaces of data to then use for research purposes. So I hope you guys are enjoying the workshop so far. We're going to go through more things tomorrow. And I would like to open for questions if you guys have any. And you can turn on your cameras now so we can finally see who we're talking to. If people didn't fall asleep and there's no one watching.
I'm here.
Hello.
Are you listening to me?
Are you
Yes.
listening?
I just need to see what is it. I just have a question. Let me see if I can ask you in English. Okay. You were saying that we can maybe do all this kind of, collect all this kind of data from the palace, from the Crystal Palace. And how do you think, is it possible to do it in a real space right now? Or is it so hard to have this, to collect all this information? How do you think is it?
How hard it is to collect the information, like the data from the environment?
Yeah, is it easy to do, or is it so hard? Like, I don't know. I really want to do a experiment like this. Do you think is it?
It depends exactly the level that you want to measure and the tools that you would like to use. For example, you could get an API, meaning that it's a piece of, you know, let's say a software that runs a camera and recognizes people's emotions. And then all you need is the software and the camera installation. And then it's about how to, let's say, again, just explaining, we're by no means trained in neuroscience. This is just some things that, you know, came up in research. And, you know, in the sense, it depends on what you're trying to measure and the scope, the actual, you know, scale of the research that you're trying to use. And of course, you know, to be a valid, you know, research with valid data, you do need to account for this idea of inclusion, exclusion, how much information you're analyzing. Because if you're getting— Is it biased? You know, because if you're collecting just, for example, and I'm about to destroy my own presentation, this would not work, the Crystal Palace research. And it was a, you know, a tool for actually, you know, talking about how research would go, but it actually has a major flaw, which is that people that visited the Crystal Palace are experiencing the Crystal Palace for the first time in an architectural space that had never seen before. So all of the feelings, emotions, and actual behavior are guided by this feeling of awe, of looking into this magnificent structure. And it doesn't really correlate to how people would experience in real life architecture day to day. So, you know, in a way, this was, you know, to exemplify some concepts, but, you know, the actual research, you can invest millions of dollars to time travel and experience, and it would not mean anything.
There's some questions in the chat.
It's better
to pick up a space where we have a lot of photos of, or is it better to choose a place we have a more of a sensory memory of? I mean, I think photos could be helpful if they wanted to use the photo, but at the same time,
oh, just a question for Larissa. Is this for a question for
tomorrow,
for the assignment?
Yeah.
Okay. I think it's a space that you believe would be interesting for, it's a space that you believe would be interesting for a research like that, regardless if you have pictures of it or if you have memories of it. Perhaps you just know about it. For example, if I was picking a building in Brazil, perhaps I would go with MASP in Sao Paulo, which, you know, the museum by Lina Bobardi, and there's a huge like space underneath. And I never grew up in Sao Paulo, and I've been to the building a couple of times. I don't have memories or pictures of it, but it's just picking something from the place you're from that you think you would be interesting for this type of research.
Yeah, I think, but I also understand what they're saying because of the whole, like if we're giving dance, for example, like an image, the more data you have of something that could also inform. I mean, not for specifically.
Yeah, tomorrow's workshop doesn't necessarily need to be the same building or anything related.
You just submit something for the assignment and then do something entirely different for what we're doing for the workshop tomorrow. So if you want to pick some place that you don't have any pictures of and it's just some place that interests you, like go ahead and do that. And then if you want to use images of something else for tomorrow's workshop, then you can do that as well.
All right.
Can I ask you just one more thing? Can I choose a place that I don't think is a good place for human beings to be inside, or do you think I need to choose a place that is good for human beings?
Actually, yeah, you can go the other way.
Because I already have a place that I really want to do a neuroscience study there. I think maybe you know, but I will take this one for this assignment.
I think that's even kind of like, that would also be super interesting because then you're just trying to prove like, okay, what isn't working here? Like, how is someone's experience bad here and why? Like, what is the quantitative data that makes this experience this way? So, you know, that could actually prove that it's not just like a gut feeling that you feel about the space. There's actual data.
Amazing. I like it. Thank you.
Lori, you're here with us. Would you like to say anything?
Yeah, just to say that it was amazing. You can use all those methodologies to do a lot of things, and you were really clear when you are exposing yourself, your ideas, and it's so amazing to see how young people are working on it, and it's so amazing for us that we are researching for a long time, and to see how this young blood is arriving in this field, in this kind of experience. And it's so clear, you are so depth in your explanation, and the way that you and Ligia could create all this atmosphere. I know that everybody's here with us at this moment are crazy for tomorrow because everybody's thinking a place or bad or a good one just to choose. And this experience is so translatable for our day by day in our offices, in our studios. And it's so amazing to know that we can use it. I know that this kind of technologies, it's not possible to everyone to use nowadays, but we have a lot of people researching like you both, and this kind of knowledge, this kind of experience, this kind of sharing moments like this one is going to be amazing to everybody. We are always learning, and with you too this night we learned a lot. Thank you very much, and congratulations for the clear and precisely a presentation.
Thank you. Thank you so much.
Anyone else have any questions?
I do.
Oh my God.
Oh my God, sorry. I just want to know, where can I find this assignment? And I want to see your study. Are we going to have your information? Because I want all this, the process. You said biophilia, you said the light, the aspects that we need to think about the place.
We're sharing the recording tonight. Yeah, we're sharing this presentation as well as the recording tonight.
Okay, where?
In the group chat?
In the group chat.
And there is a group chat? Okay.
Yeah, I do.
Yes.
I didn't know. Okay, thank you.
All right. Well, if anyone has any questions following this, be sure you can contact us, message us if you have any questions about the assignment per se, about anything regarding tomorrow or the recording. And we will see you tomorrow. So thank you very much for being here today.
Thank you. See you guys.
See you.
Thank you so much.
Thank you so much, guys.